We're practically drowning in data every single day, right? It's in the news headlines, economic reports, the latest diet craze. It's everywhere. But how much of that is a real, meaningful pattern, and how much is just, well, random noise? So, in the next few minutes, we're going to dive into the powerful tools that help us model reality and tell the difference between an actual fact and pure random chance. And this right here is the million-dollar question. Imagine you launch a new ad campaign and boom, sales go up. That's fantastic. But wait a minute, did the ad actually cause that spike? Or did you just happen to have a lucky week? Getting that right? Well, that's the difference between a brilliant marketing move and just throwing your budget into a black hole. So, to get a real answer, we definitely can't just rely on a gut feeling. We need a system, a process. Let's talk about how to make a proper, educated guess. And more importantly, how to turn that guess into something you can actually test. And that educated guess, it has a name, a hypothesis. Now, the key words here are clear and testable. A vague idea like, my ad might help sales, just isn't going to cut it. A strong hypothesis is super specific, something like, this new ad campaign will increase our average weekly sales by at least 10%. See, that's something you can actually sink your teeth into and measure. Okay, now this is where things get a little weird. A bit counterintuitive, but trust me, it's incredibly powerful. When we test things statistically, we start by playing the ultimate skeptic. We actually begin with the assumption that our great idea is totally wrong, that there is no effect whatsoever. So this really shows you the two competing ideas at the heart of this whole process. On one hand, you've got your educated guess, which we call the alternative hypothesis, your big idea, like the new drug works. But we have to test it against the default position, the null hypothesis. That's the skeptic's view that says the drug has no effect. Our entire mission here is to find so much evidence that we can confidently throw out that default no. Okay, so how do we actually do that? How do we try to reject that default no? Well, we put our data on trial. Seriously, think of this next part like a courtroom drama, but for statistics. And here's the core principle of that courtroom. The null hypothesis is presumed innocent until proven guilty. Your data, that's all the evidence you've got. And the standard of proof is really high. You need some serious, compelling evidence to overturn that innocent verdict of no effect and declare that, yes, something real is actually happening here. And this trial follows 4 very clear steps. 1, you state your 2 competing claims, the null and the alternative. 2, you start by assuming the null is true, that nothing's going on. 3, you go out and collect your data, and then you ask, okay, if there was really no effect, how weird, how surprising is the data I just found? And 4, if your data is so surprising, so unlikely that it almost certainly isn't just random luck, then, and only then, can you reject the no. So let's say you do it, you succeed, your evidence is overwhelming, and you reject the null hypothesis. Ha! Your ad campaign worked. But that only answers the yes or no question. It doesn't tell you the part you probably care about most. How much did it work? Was it a massive success or just a tiny little bump? To figure that out, we need to pull out another tool from our kit. And that next tool is called regression analysis. If hypothesis testing is all about asking if there's a relationship, regression is what helps us find the how and how much. It lets us actually build a model of the relationship between things, turning simple data points into some seriously powerful insights. Okay, the absolute best way to picture this is to imagine a scatter plot of your data, just a big, messy cloud of dots all over a graph. It just looks like random noise. Regression is basically the magic wand, the mathematical tool that draws the best possible straight line right through the middle of that cloud, revealing the hidden trend that was buried in all that noise. Let's look at a super simple table. As the hours studied go up, the test scores also tend to go up. Pretty obvious, right? But regression takes this data and spits out a precise formula. It could tell us something amazing, like for every extra hour you study, your test score is predicted to go up by 7 points. All of a sudden, we've gone from just knowing that studying helps to a predictive model of exactly how much it helps. That's a game changer. So we've talked about hypotheses and regression, but why should any of this matter to you outside of a stats class? Well, because these tools are quietly running the modern world, influencing everything from the headlines you read to your own personal health. Really think about it. How do we know a new medicine is actually safe and effective? That's hypothesis testing. How does an insurance company figure out how much to charge you? They're using regression models to predict risk, the economic forecasts you see on the news, the ads that creepily follow you around the internet, even how we understand huge, complex systems like climate change. It all comes down to this fundamental process of testing ideas and modeling relationships in data. But what this all really boils down to is that these aren't just math concepts, they're a toolkit for critical thinking. The next time you see a claim that's backed by data, you can start asking the smart questions. What was the null hypothesis they were trying to disprove? How strong is their evidence, really? And just how big is the effect they're talking about? This is how you go from being just a passive consumer of information to a truly informed citizen. Look, our goal here was to hand you the tools to look past the flashy headlines and see the world just a little more clearly. So the next time you see a new study or a wild statistic, you'll be ready. You have the framework now. The only real question left is, what data claims are you going to start questioning first?